Okay, so this is 9.1.1, intersection of a line with a plane. So if you look at the first picture, you can see that this line and this plane are parallel and distinct. The second one, parallel and coincident, and third one, plane and line, they have point of intersection. So how do we test this? Well, first of all, M, write it here, M dotted with N is equal to 0. That means the direction vector and normal vector, the dot product of it is 0. That means M is perpendicular to N. In other words, if you look at the first one, you can see that M is perpendicular to N. All right, if this is the case, then if this is yes, then we're going to have line is parallel to the plane. So what does that mean? That means you have to find T, you substitute parametric equations of line on plane. All right, what if M times N is not equal to 0? If it's not, then line and plane are not parallel. Again, you have to find T and substitute parametric equation of line into plane. In the first case, if line and plane are parallel, if 0t is equal to a number, or 0 times t is equal to a number, that basically means no solution. And no solution means line is parallel to plane because that's parallel side and distinct. If M times N is equal to 0, that means line is parallel to plane. If 0t is equal to 0, in other words, left-hand side and right-hand side are equal, we have infinite number of solutions. Infinite number of solutions. So what does that mean? That means a line and plane are parallel and coincident. Now, what would happen if line is not parallel to plane? Well, you have to find T by substituting parametric equation of line into plane, and then you get T is equal to a number. So what does that mean? That means we have a point of intersection. Okay. And use PE of line. All right. So the first example says find the section of plane of this and the line of this. Now, this one, it tells you that this is basically there's an intersection. But what if it doesn't tell you it's an intersection? So what we're gonna do, we're gonna find the if there is a point of intersection actually. So the first thing we're gonna do, this is not what it's asking, but I'm gonna do it. So m times n, or a dotted with n, is equal to 0. I'm going to check this by putting m, that is 1, 5, and 0, dotted with 5 and 5 minus 1 and 2, and we get 0. When you multiply these two together, you get 0. So this means that line is parallel to plane. So if line is parallel to plane, what we have to do, we have to find t. In other words, we have to substitute parametric equation of line into the plane. So let's find parametric equation of line and then put it into the plane. So parametric equation of line x is equal to minus 4 plus t, y is equal to 6 plus 5t, and z is equal to minus 1 plus 0t, or just minus 1. Now you want to put this one into the plane. The plane is right here. So I'm going to, instead of x, I'm going to put minus 4 plus t. And I do the same thing for y and z. So minus, instead of y, I'm going to put 6 plus 5t. I'm putting the line, parametric equation of line, into the plane. And then plus 2 times 1 plus 7 is equal to 0. Now, when this gets simplified, we end up with 0t is equal to 0. So what does that mean? That means there is no solutions. We get 0t is equal to not 0. We get 0t is equal to 21. So what does that mean? That means this is impossible because 0 times a variable cannot be 21, it's only 0. So no solution. That means the line and plane are parallel and distinct. So line is parallel to plane and distinct. The next question says, find intersection of plane and a line. Again, it tells you that there's an intersection, but it doesn't tell you what kind of intersection. So the first thing I'm going to do, I'm going to put m times n dot product to see if this is equal to 0. Now, when I put this times this, and I get 0. So what does that mean? That means a line is parallel to the plane. Next, I have to find t by substituting parametric equation into the plane. So find parametric equation. You know what? I'm not going to find parametric equation. I'm just going to put it into the plane. So instead of plane, I'm going to write this is my x plus 4 times this one minus 2 times this one plus 3 equal 0. So now I'm going to put my parametric equation of a line. So parametric equation is minus 3 plus 2t. And the second one is 1 plus 3t. And 2 plus 7t. So if I do this, I'm going to end up with, if I multiply everything together, I get 0t is equal to 0. So what does that mean? That means I'm going to have infinite number of solutions. So that means line is parallel to plane and coincident. In other words, line is on the plane. Find its intersection point of plane and line. So again, this one, it tells you that there is a point of intersection. You notice here, there's no, well, there's many point of intersections. That's because line is on the plane. The first one did not have point of intersection, or there is no intersection. The last one, it tells you that find the point of intersection point. But again, I'm going to go and find the dot product, m times n. And if I multiply these two together, like 3, 6 minus 4 times 2 minus 3 and z, I get 16, which is not equal to 0. Because it's not equal to 0, that means a line is not parallel to the plane. So our next step is to find the parametric equation and put it into the line. I'm going to do it in one step. So I'm going to say 2, this is the line, 2 times something, minus 3 times something, plus 1 times something, why not, plus 5 equals 0. So now I'm going to put the parametric equation into this one. Parametric equation is 7 plus 3t. And this one is 14 plus 6t. And minus 9 minus 4t. If I do this and simplify it, I get t is equal to negative 2. Because I have a number, I have a point of intersection. Therefore, I use a parametric equation of line to find the point of intersection. Okay. So t is equal to, now I'm going to put it into parametric equation of line. Parametric equation of line was x is equal to 7 plus 3 times negative 2. Y is equal to 14. So plus, plus 14 plus 6 times negative 2. And z is equal to minus 9 minus 4 times negative 2. And these numbers are minus 1 plus 1, 2, and minus 1. Yeah. So point of intersection is 1, 2, and minus 1. Okay, so this part is still part of 9.1, but this is intersection of two lines, and yeah. So, um, so two lines can be on top of each other, like the first one. They're parallel, but they're coincident. The second one is parallel and distinct. The third one, you have point of intersection. And the last one, these are skew lines. All right, so the rule of thumb is this. The first thing you have to do when you have two lines and you want to find sectional intersection, if there is if there's any intersection between them, is to say, you know what, direction vector of one line is equal to k times direction vector of the second one. Why? because you want to know if they're parallel or if they're not. If they're parallel, it's going to be coincident or distinct. If they're not parallel, it's going to be skew line at the point of intersection or um, uh, skew lines. All right. So if they're parallel, yes, if this is correct, that means line 1 is parallel to line 2. That means the first case and second case. So the question is point on line 2, is this point on line 1? Because if it is, we're going to have coincident. Coincident. If point of line 2 is not on line 1 or the other way around, that means we're going to have no. That means we're going to have distinct lines. All right. So what would happen if these two are not equal? In other words, the lines are not parallel. That means line 1 is not parallel to line 2. When you get this kind of situation, then you have to use, or maybe I shouldn't say use, I should say equate parametric equation to each other. So parametric equation of line 1 is equal to parametric equation of line 2. Y1 is equal to Y2, and Z1 is equal to Z2. Why do we do that? Because we want to find S and T. Once we find S and T using two equations, then you put S and T, put them in third equation. So when you put it in third equation, so in third equation, or equation 3, you're going to ask, is left-hand side is equal to right-hand side? If it is, that means we're going to have point of intersection. And to find point of intersection, you put or you use S and T in line 1 or line 2 to find point of intersection. Now, in equation 3, if left-hand side is not equal to right-hand side, then we're going to have skew lines. Oops, skew lines. All right, so the first question, you have two lines in 3 space is given to you. So first, we're going to put M1 is equal to M2, KM2. I want to see if they're parallel. When I put them, I get maybe I should write it down. 2, 4, 6 is equal to 1 times 2, 4, 6. In other words, line 1 is parallel to line 2. So in other words, it's the first case scenario. Now you put P2 on line 1. I can change it to parametric equation, or I can just do it right here. So I'm going to do it right here for this question. So I'm going to say put, it doesn't matter. You can put P1 into line 2 or P2 into line 1. You know what? I'm going to put P1 into line 2. So if I put P1 into line 2, I'm going to get 1, 2, 3 is equal to 3, 6, 9 plus T times 2, 4, and 6. Let's see if I get the same T values. So if I continue with this, I'm going to get 1 is equal to 3 plus 2T. And T becomes, this goes the other side, becomes minus 1. If I use 2, I get 2 is equal to 3 plus 2T. Not 3, 6 plus 4T. And this becomes 4 minus 4. So again, T is equal to minus 1. The third one, 3 is equal to 9 plus 6T. Again, this becomes T is equal to minus 1. Therefore, line 1 is parallel to line 2 and coincident. In other words, they have infinite number of solutions. Let's go over next. Next one, they give you basically standard equation or equation of line in standard form. You can think about it. The easiest way to think about it is to change this one in terms of what you learned earlier in grade 10 or 9, when you say y is equal to 7 minus 2x and then divided by 3. This is x. If you do that, I'm going to have this. So I do the same thing for the second one. So y is equal to 15 minus and I divided by minus, so this is positive. And the second one is 15 over 8 over 12 minus 8x over 12. Actually, you know what? You can simplify it. So let's simplify it. First of all, this becomes negative, and this becomes positive. So let's simplify this. So this becomes y is equal to divided by 4, 2x over 3. And this is divided by 3 is 5 over 4. So if you look at the slope of this line and slope of this line, they're equal. So in other words, the slope of this one is equal to the slope of this. So not vector, these are slopes. They're equal. Well, so what does that mean? That means line 1 is parallel to line 2. Now I'm going to look at the y-intercept. If I'm looking at y-intercept, this y-intercept and this y-intercept, they're different. In other words, well, not D, but C, if you wish. C1 is not equal to C2, therefore, they're distinct. In other words, there's no point of intersection between those two equations or lines. So they give you something like this, and they say something like determine the point of intersection if exists. Okay, so what do we have to do? We have to find, we have to realize if these two are parallel. Well, let's see. M1, 1, 4, and -2. Is it equal to k times -2, 8, and 4? If I do that, k is equal to 1 over, so -1/2. For the second one is -1/2. For the third one is -1/2. Therefore, line 1 is parallel to line 2. Then, because they're parallel, we want to put one point of one of those lines on the other line to see if they're coincident or distinct. So I'm going to put, this time I'm going to put P2 on P1. So I'm going to put 10 and 26 and 7. So 10 is equal to, so I'm going to put 0.2 in line 1, parametric equation of line 1. So 3 plus t, 26 is -2 plus 4t, and the last one, 7, is 5 minus 2t. If I solve for t, I get t is equal to 7. T is equal to 7. For this one, t is equal to -1. In other words, they're not equal. Because t's are not equal, line 1 is parallel to line 2 and distinct. Go with this one. Again, the question is asking something like this. It says, I give you these two lines, determine point of intersection if any exist. So again, the first line, the first step is to say, all right, M1, 4, 0, and -1 is equal to k times M2, 9, -2, and -2. So k is equal to 4 over 9. Is it equal to -3? No. Is it equal to 1 over 2? No. Therefore, line 1 is not parallel to line 2. So they're not parallel. It's back to here. They're not parallel. That means I have to put parametric equations of line 1 and line 2, equate them together to find S and T. Once I find S and T, you put them in the third equation, because this is 3 equations, 3 unknowns. And in the third equation, if I have left-hand side is equal to right-hand side, I have point of intersection. If I don't, I have skew lines. So I'm going to put one point into no. I'm going to put the parametric equations equal to each other. So the first parametric equation, I have 2 plus 4t. This 1 plus 0t. You know what? I'm going to write it down. 1 minus t. The second parametric equation from the second line is 3 plus 9s minus 1 minus 2s and 1 minus 2s. Okay. Now, if I simplify this, I get 4t minus 9s is equal to 1. This goes the other side, so s is equal to minus 1. And this one becomes t minus 2s is equal to 0. All right, so this one is kind of easiest or easier kind of equation set of equations. If I put s into the top one, and I want to solve for t, I'm going to get, so I'm going to start from here. So 4t minus 9 times minus 1 is equal to 1, and t is equal to minus 2. Now, if I put s and t into the third equation, so this is minus 2 times minus 1, that's s, is equal to 0. So if I look at this, I have 0 is equal to 0. That means left-hand side is equal to right-hand side. This is the third equation. So therefore, I'm going to have point of intersection. But how am I supposed to find point of intersection? Well, I can put S and T in either of these two and find the values. So I'm going to put S in my notes. I put S and T in the first line or parametric equation of first line. Now I'm going to put it on the second line. See if I get the same answers. So I'm going to have x is equal to 3 plus 9 times t is minus 2. Y is equal to minus 1 minus 2 times, ooh, I made a mistake. This is s, so it's minus 1. That's a mistake. This is minus 1. Why? Because this is what I'm looking at. S. Minus 1. So 2 times minus 1. And z is equal to 1 minus 2 times minus 1. Let's see. So this is 3, that's minus 6. This one is 1 plus 2, that's minus 1 plus 2, that's 1. And this one is 1 and 2 is 3. So point of intersection is 6, 1, and 3. Again, what I did in my notes, I put I put t in the first parametric equation or parametric equation of line 1, and I got this number. As extra practice, I did here I did s into the second parametric equations to double check, and yes, I get the same point of intersection. Next, it says basically the same thing as this line. It says determine point of intersection if it exists. Okay, so the first thing you have to do, okay, so again, the first thing you have to do is to see if these two are parallel. So I'm going to say M1 is equal to km2, these two direction vectors. So k is equal to 3 over 3, that's 1. 1 over minus 1, this is minus 1. And minus 5 over 4. So what does that mean? That means line 1 is not parallel to line 2. That means I'm going to have point of intersection, or I'm going to have skew lines. Which one? So the next step is to go to, oops. So the next step is to go to put parametric equations equal to each other to find S and T. And then you put that in third equation to see if left-hand side is equal to the right-hand side. So first, parametric equations. So the first one is 2 plus 3s. Second one is minus 1 plus, oops, not st. Minus 1 plus t, and 4 minus 5t. This is equal to the second line. Parametric equation of second line is 5 plus 3s, 0 minus s, or minus s, and 1 plus 4s. If I simplify these ones, I get 3t plus 3s is equal to, oops, minus 3s, minus 3s. So I take 3s to the other side, is equal to 3. The second one is t plus s is equal to 1, and minus 5t, I'm simplifying these lines, minus s equals minus 3. So solve two of the equations, find s and t, put it in third one. Okay, which tool do I want to find? I'm going to simplify this line because I can see I can simplify this. If I simplify this divided by 3, I get t minus s is equal to 1. And this one is t plus s equals 1. So I can divide the subtract these, and I get 2t is equal to 2, and t is equal to 1. Now that I have t is equal to 1, I use the second equation. For second equation, 1 plus s is equal to 1, so s is equal to 0. Now I'm going to put it in the third equation. So minus 5 times 1 is 5, and this is 0 because of s is equal to minus 3. So now I'm going to have minus 5 is equal to minus 3. Is that correct? No. Therefore, because these left-hand side is not equal to right-hand side, therefore I'm going to have skew lines. And I stop right there. Next equation. Next one is this is from example 5 of Nelson. The same thing. It says find point of intersections. I'm going to say, okay, so are they parallel? So is M1 is equal to KM2. Direction vectors. are equal or multiple of each other. So I get k is equal to -1 uh, and 1 over 4. So that means they're not equal. I'm going to continue with this one, 4 over 6. So these are not equal. Therefore, line 1 is not parallel to line 2. I have two options. I get point of intersection or skew lines. Which one? First, I have to equate the parametric equations together. So I'm going to say minus 3 um, minus s equals, I'm looking at line 1. The second one is 1 plus s equals, third one, 4 plus 4s equals. Now, the parametric equation of line 2, 1 minus 6t, 4 minus t, and 6 plus 6t. I'm going to simplify these ones. I get minus 6t plus s is minus 4. Simplify this one, it gets t plus s is 3. And the last one is 6t minus 4s is minus 2. Okay. Looking at line 1 and line 2, I can simplify it. I can find s and t with those two easily. Let's see if I can do something else. If I divide, nah, I'm not. Okay, so it's easier to do it with line 1 and line 2. But for that, I'm going to multiply line 2 with 6 to get rid of t. So I get minus 6t plus s is equal to minus 4. And this one is 6t plus 6s is equal to 18. If I do that, I get rid of t's, and I have 7s is equal to 14, and s is equal to 2. Have s, I'm going to put it in second equation. So t plus 2 is equal to 3, and t is equal to 1. Now I'm going to put it in third equation to see if left-hand side is equal to right-hand side. I can simplify it, but I don't want it to because it's not necessary. So 6 times 1 is 6. I'm looking at this. Minus 4 times 2 is 8. Is equal to minus 2. Okay, minus 2 is equal to minus 2. Yes, left-hand side is equal to right-hand side. We're going to have point of intersection. Now, we're going to have point of intersection. Where do I have to put S and T? Do I have to put it in parametric equation of line 1 or parametric equation of line 2? It doesn't matter. In my notes, I put it in parametric equation of line 1. Here, I'm going to put it in parametric equation of line 2. So I'm going to use the red one. So x is equal to 1 minus 6 times 1 is 6. That's minus 5. Y is equal to 4 minus 1. That's 3. And z is equal to, this is z, is equal to 6 plus 6. That's 12. So parametric point of intersection is 5, 3, and 12. Oops, minus 5. And in my notes, I get the same thing. In my notes, what I did, I put S and T in parametric equation of line 1. But it's the same answer. Let's look at example 6 of Nelson. So it's the same thing. It says determine the point of intersection if exists. So the first thing I'm going to do, I'm going to say M1 is equal to KM2 to see if they're parallel. Now, M1, I'm going to do this one. That's 1, 4, and 5 is equal to K times -1, 2, and -5. So if I do that, I get K is equal to -1. Um, uh, but this is not equal to 2, and it's not equal to -1. Therefore, we have line 1 is not parallel to line 2. Because line 1 is not, because line 1 is not parallel to line 2, we're going to have these two cases. We're going to put parametric equation of line 1 is equal to parametric equation of line 2, solve for S and T, and then put it in the third equation. If left-hand side is equal to right-hand side, we have point of intersection. Otherwise, we have skew lines. So let's do this. So first, I'm going to write the parametric equation of line 1. Parametric equation of line 1 actually is given to me. So -1 plus S, 3 plus 4S, and 6 plus 5S. Parametric equation of line 2 is 4 minus T, 17 plus 2T, and 30 minus 5T. If I simplify it, I get S plus T is equal to 5. 4S minus 2T is equal to 14. And you know what? I'm going to write it down, but I'm going to write it with a different color. So I have 5S, this is the third one, 5S plus 5T is equal to 24. Now I'm going to choose the first two because it looks easier. So I'm going to multiply this one by 2. And if I multiply this one by 2, I don't have a space here, but I get 2S plus 2T is equal to 10. And I have 4S minus 2T is equal to 14. And you notice that you can cancel out these two. You get 6S is equal to 24 and S is equal to 4. Now I'm going to put it in one of these two equations. I'm going to put it on the first one because it's easier. So 4 plus T is equal to -5 and T is equal to 1. Now I'm going to put these two values in the last equation. So I'm going to have 5 times 4 plus 5 times 1 is equal to 24. Let's see. That's 20 plus 5 is 25. 25 is not equal to 24. Therefore, we have skew lines.